Welcome. In this video, we are going to see design and verify wave shaping circuits. Under wave shaping circuits, we are going to look at clipper circuit or clamper circuit. Clipper and both clamper circuit. So this we can do it using hardware components, or we can also simulate using LTSPICE. So in this pandemic mode, so you are at home, so we are going to simulate this using LTSPICE. Okay. Let us look at what is clipper, okay, and then we will do how to simulate it using LTSPICE tool. So clipper is an electronic circuit by which the waveform is shaped by removing a portion of the applied waveform above or below a certain level. Clipping, okay, it is meaning that we can remove a particular wave, okay, which we don't need, okay. So that is what is the meaning of clipping. So there are varieties of clippers, okay. We used to name the clippers as positive clippers, negative clipper, biased clipper, and a combinational clipper. So let us see how the different clipper circuits will be, okay. Look at, so this is positive clipper. A positive clipper is one which removes the positive half cycles of the applied input voltage. So here the input voltage is a 5 volt peak to peak sinusoidal voltage we are applying here, okay. This clipper design is using a diode, okay. The output voltage has all the positive half cycles removed. Only we will get the negative half cycles in the output voltage. The positive half cycle of the input voltage, during the positive half cycle of the input voltage, what happens? The diode, okay, is in forward biased and it is conducting heavily. So therefore the voltage across the diode is 0. Hence across the load resistor, okay, hence across this diode, okay, what we'll get? So we are measuring across this diode only, okay. So we will get the voltage at the time is equal to 0. So here we are given some biasing here. So here biasing is given as 2 volt. So here in this case we will get the biasing voltage output, okay. So in this case we will get the biasing voltage output. This is what a biased clipper. Now suppose if we don't give any supply voltage here, okay, at the time only we will presenting diode only over here. What happens at the time? So at the time we will get only negative half cycles. All complete positive half cycles will be removed. Suppose if we are giving 1 volt, 2 volt, 3 volt, so that is less than 5 volt, okay. We should maintain this bias voltage less than 5 volt. So if we give a particular portions alone will be removed, okay, depending upon the bias voltage that we will use to see it in the simulation, okay. Let us see the simulation of this biased clipper, okay. Let us see the simulation over here. You can look at under LTSPICE, we had opened a new schematic symbol, okay, and I had select the components over here. What are the components I need to create a clipper circuit? I need what are the components I need? I need a voltage source in order to generate a sinusoidal voltage. I had generated a sinusoidal voltage with the frequency of 1 kilohertz, okay. You can look at here amplitude 0 to 5 and frequency of 1 kilohertz I had generated. Then we are using a current limiting resistor and a diode, and I am using another supply voltage. Here I had maintained supply voltage as 3 volt, okay. This is a bias voltage, okay, and this circuit is a typical positive clipper with biasing voltage. You can look at here. So this is the typical circuit we had taken. So positive clipper with some biased voltage. Let us see how this will works, okay. So here during run I had given the transition time as 1 millisecond, okay. Now I am going to run this circuit, okay. You can see the waveform over here, okay. Yes, so here the positive voltage alone is get biased. Okay, up to 3 volt we are getting. Okay, above 3 volt the positive voltage 4 and 5 volts are here, it is clipped off. Okay, you can see the full waveform under the negative half cycle. Okay, this is how the positive biased clipper will gives you the output waveform. Okay, let us recall what is a biased clipper once again. A biased clipper is one in which some portion of the positive or negative half cycle of the applied voltage is removed. Okay, the biased clipper consists of a diode with a battery of and with a battery of few volts. Okay, this voltage should be less than the input voltage. Okay, a portion of each positive half cycle will be clipped. Okay. And if we change the bias voltage to negative, okay, accordingly also the voltage will get removed, that is from the main voltage, okay, from the supply voltage. Here the diode will conduct heavily, so as long as the input voltage is larger than the biased voltage. Okay, when the input voltage is larger than the biased voltage, the diode acts as a short circuit and the output will be equivalent to the biased voltage, that is it is equivalent to nearly 3 volt here. When the output will be equal to the biased voltage, so here it is a 3 volt, so as long as the input voltage is higher than the biased voltage. So most of the applied input voltage appears across the output. Okay, so this is the process of obtaining a biased clipper. So in this way we can design a negative clipper. You can look at here in the design of negative clipper, we had altered the direction of the diode as well as we had given a negative voltage. Okay, let us see how the waveforms will be. So similar way we can look at the input waveform. So an example of an input waveform and output waveform of positive biased clipper, it will be like this. So this is what we had seen in the LTSPICE simulation. Then you can see the negative clipper how it is. Okay, and next circuit is about the clipper circuit. One more circuit in this wave shaping we are going to look at as a clamper circuit. Okay, clamper is a circuit. Clamper is a circuit which shifts the positive or a negative peak of a signal, which shift the positive or negative half of the signal, clamper is a circuit which shifts the positive or negative peak of a signal at a desired DC level. A clamper, it will essentially adds a DC component to the signal. Here again we can design a positive clamper or a negative clamper. So this is the positive clamper design. So you can look at in the clamper circuit, the main component here we are using as an capacitor, okay, to hold the charge. Okay, capacitance is the main component here we are using. You can look at the difference between the clipper circuit and a clamper circuit. Clipper circuit here in this case we are using a current limiting resistors. So here we are using a capacitor. Okay, and across the diode a parallel load resistance is given here. Across that only we are going to take the output. So this is a clamper design. So this is for a positive clamper, how to place the diode, and for negative clamper how we are placing the diode. Reverse the diode position for the negative clamper. A positive clamper is one which shifts the applied signal entirely into a positive side. So you can look at a similar waveform of this positive clamper. So you can see the level. Okay, so it is not in 0. Okay, it is shifting the levels to a positive voltage here. So negative clamper, it will shift the levels to a negative voltage here. So this is an example waveform it is given to you. So okay. And we can also design biased clampers also. We can also go with the biased clampers also. We can move the levels what we need accordingly. Okay. So generally the clamper circuits are used in television receivers to restore the original DC reference signal to the video signal, and it is also used to produce a DC voltage whose values multiples of peak AC input applied voltage. So these are all few examples of clamper circuits where it is used. Okay. What you are going to do is you are going to draw all the circuit diagrams, and you are going to draw the typical waveforms of positive clipper, negative clipper, positive clamper and negative clamper. And here one example is given to you in the LTSPICE simulation. Similarly, all the circuit diagrams are given in the observation component. You just look at all the circuit diagrams and you can give your own value for the input voltage and the biased voltage and simulate and submit the experiment. Thank you. Thank you for watching. We'll meet you in the next experiment.